Here I would like to introduce a very nice problem of Turkish Mathematical Olympiad edition 2005 and 2006. Here is the following information. Find all triples m, n and k as a non-negative integers such that we have this equation 5 to the m plus 7 to the n equals k cubed. Okay, we are going to use the congruency here. We are going to reduce too many steps, so it will be easier to solve this one. Okay, so let's go through this one. So we have this following statement. So the next thing up, I'm going to reduce this one to the mod 7. So we'll have 5 to the m is congruent to k cubed mod 7. So next up, if you take a look carefully here, we have 5 squared, which is 25, is congruent to 1 mod 7. If you calculate this difference, we have 21 minus 1, which is 24. 24 is a multiple of 7, or 24 is divisible by 7. Okay, now since we know this 5 squared is congruent to 1 mod 7, so I'm simply going to raise anything here as a power. I get the same thing. Okay, so because let's check 5 to the 2x equals 5 to x, 5 to the 2x is congruent to 1 to the x is congruent to 1 mod 7. So what's this one telling us? It's telling us m is an even. Okay, is an even because it's written on the form of the 2 to the x as an exponent. Let's set m equals 2x like this. Since we know m is an even, I'm going to take this value of m and insert it into the original equation. So I will have 5 to the 2x plus 7 to the n equals k cubed. Okay, we'll have 25 to the x plus 7 to the n equals k cubed like this. Okay, so another nice thing here, if you take a look at this expression, so we have this term is odd, this term is odd, which means the sum of these terms must be even, which means k cubed is a even, which means k is a even. It's telling us k is a even. If k is a even, which means k must be written on this form, k equals to p like this. Okay, we will have 25x plus 7 to the n equals 2p cubed, which means equals 8 p cubed like this. 25 is the same as 24 plus number 1 to the x plus 8 minus 1 to the n equals 8 is multiplied by p cubed. Okay, if I'm going to reduce this one to the mod 8, is turned to 0, this 1 to 0, this 1 to 0 is congruent to 0 mod 8 like this. Okay, so I will be ended with 1 plus minus 1 to the n is congruent to 0 mod 8. Okay, so what do you think about this one? In order to have 8 divides this one, so this n must be odd. If n is odd, which means this one is turned to minus 1. If minus 1 plus 1 is turned to 0, which means we have 0 is congruent to 0 mod 8, which means 8 divides 0. Okay, which means n must be odd. Okay, so we have collected these three informations. We get m equals to x, we get n is odd, we get k is even, k equals to p. Okay, now let's go through the chart now. So I have the following values: n, I have n squared, I have n cubed. So this one is going to be reduced to the mod 7. Okay, so let's stick the following values. We'll have 0, 0, 0. We'll get the next value 1, 1, 1. The next value 2 squared, which is 4. 2 cubed, which is 8. 8 is 1 more 7. It's a congruent to 1 more 7. Okay, let's check the next value 3. 3 squared, which is 9. 9, we have 2 more 7, which is 2. Let's check 3 cubed. I'm simply going to multiply this one by 3. 2 is multiplied by 3, which is 6. I get 6 here. Let's check the next value 4. 4 squared, which is 16. 16 is 2 more 14. Okay, like this. Let's check the next value. Next value, I'm simply going to multiply 2 by number 4. Okay, so we'll get 4 is multiplied by 2, which is 8. 8 is 1 more 7. Let's check the following value. I get 5. 5 squared, which is 25. 25 is 4 more than 21. So the next one, I get 5 is to get cubed here. To get 5 cubed, I have 5 is multiplied by 4, which is 20. Is 6 more than 14. Okay, so I'm going to stop here because this one is enough. If we take a look at here, this one is keep repeating 6 1 6 1 6 1 and all the way down. Okay, so I have n cubed. I have 0 and 1 and 6. So I have 0 and 1 and 6 are only perfect cubed mod 7. Okay, so we already know m is even, so which means I will have 25 to the x plus 7 to the n equals k cubed. Okay, now if I'm going to reduce this one to mod 7, so I get k cubed is a congruent to, we know 25 is 4 more than 21, which is is a congruent to 4 to the x mod 7. This one is going to be 0 because we know 7 is divide 7. So we'll have 4 to the x mod 7. Okay, so if I'm going to back to the chart, so we know this one is expressed as n cubed as a q cubed here, which means 4 to the x and q cubed must have the same remainder. Okay, so in order to have the same remainder, the only thing to get the same remainder, we must give x equals 0. Okay, if we give to the x 0, I will get here 1, which is this one. Okay, otherwise we cannot have any remainder on this form because this one is a power of 4. Okay, x must be equal to 0. Okay, if x equals to 0, this one is turned k cubed congruent to 1 mod 7. Okay, which means this number 1 here is the same as this number 1. So which means k cubed and 4 to the x have the same remainder, which is number 1. Okay, now since we determined x equals 0, I'm simply going to replace x with number 0. Okay, so I get here m equals 2x equals 0. Okay, if I'm going to take this value of m and insert it into the original equation, I get here 1 plus 7 to the n equals k cubed. Okay, like this. Now I'm going to bring this one at the top and continue solving our equation. So previously we were working on this equation and came up with this result. So now I'm simply going to push this number 1 to the right. I will get 7 to the n equals k cubed minus number 1. Then it's more easier now to factor out this one. This one is the same as here, k minus 1 factor k squared plus k plus number 1. Okay, so if you take a look at both sides of this equation, we know the left hand side of this equation is a power of 7. which means the right hand side of this equation must be a power of 7 as well. So in addition, we know 7 is a prime, which means GCD of these terms, let's call it as a capital A and k minus 1. This one, let's put it as a capital A. GCD equals 1 or 7, either one. Okay, so by the way of contradiction, suppose GCD of these terms k minus 1 and capital A equals 7. Okay, equals D equals 7, which means D equals 7 divides k minus 1. Okay, are going to go through this one. So which means k minus 1 is a multiple of 7. Okay, if k minus 1 is a multiple of 7, which means k minus 1 equals 7 is multiplied by another non-negative integer c. Okay, then this one is telling us k equals 7 c plus number 1. Okay, by taking minus 1 to the right side of this equation. Then I'm going to take this found fact and insert it into the original equation to see what's given us. So we'll have 7 to the n plus number 1 equals k cubed, which is 7c plus number 1 cubed. By going to distribute this one, we'll get 7c plus number 1 square is multiplied by 7c plus number 1. This one is giving us 7c square, which is 49c square, plus 2 times this one, which is 14c plus number 1. Factor 7c plus number 1. I'm going to distribute this one. I will get 7 to the n plus number 1 equals 49 is multiplied by 7, which is 343. 343 c cubed plus 49c square plus 14 is multiplied by 7, which is 98 c square plus 14c plus this term 1 is multiplied by 7c, which is plus 7c plus number 1. Okay, I get this number 1 cancelled out from the left and the right side of this equation. Then the next thing up, I'm going to simplify this one more. So by dividing both sides by number 7, we'll get 7 to the n minus 1 equals here, this one become 46c cubed. This one becomes 21 plus 21c square. This one becomes 3c. Okay, this term is odd, this term is odd, becomes even. Even plus even is given as even, but which means the right hand side of this equation is even, but the left hand side of this equation is odd, which is contradiction, which means what we have contradicted, GCD of these terms is not equals to 7, equals to 1. Okay, GCD of k minus 1 capital A equals 1, not 7. If equals 1, it's simply going to replace k minus 1 equals 1. Okay, if k minus 1 equals 1, which means k equals 2. If k equals 2, I'm simply going to replace k with number 2 to find the solution for this equation. So which means I will have 7 to the n plus number 1 equals 2 cubed, which is 8. I will have 7 to the n 8 minus 1, which is 7. So which means the exponent n equals 1. Okay, so I have determined the solution for this equation. So we'll have this trips m equals 0 and n equals 1 with k equals 2. Okay, let's check if n strictly superior than 1 to have, we may have another solution or no. Okay, so this one, I'm going to transfer this one into the equation system. So we'll have 7 to the n, we'll have 7 to the, since left hand side of this equation is a power of 7, which means the right hand side of this equation is a power of 7 as well, which means 7 to the I equals k minus 1 and 7 to the j equals k square plus k plus number 1. Okay, where j strictly superior than I. If you try to compare this one and this one, always j strictly superior than I. If n, as we know, the exponent n equals a plus j, okay, because we have this product. If n is strictly superior than 1, okay, which means equals a plus j is superior to 2, okay. So I'm going to add this one on this one. I get 7 to the I plus 7 to the j. I get k square plus 2k. Number 1 will be eliminated. This one is given as k is multiplied by k plus number 2. Okay, like this. Also, I'm going to factor out this one. So I will have 7 to the I factor to the j minus I plus number 1 equals k is multiplied by k plus number 2. Like this, okay? So based on the previous solution, we found k equals 2 when we have n equals 1, okay? If I'm going to replace k with number 2 here, I will get 2 minus 1, which is 1, which means 7 to the I equals 1, which means I equals 0. But we are not talking about this case. We are talking about when we have a is superior to 1, like this, okay? Which means if I is superior to 1, which means GCD, which is k minus 1 and k square plus k plus number 1, this must be superior to 7, okay? Because if I is superior to 1, which means this one becomes a power of 7, okay? If this one is a power of 7, this one must be a power of 7 as well, because as this one is going up, this one is going up as well. So which means GCD of this one is always must be superior to 7, which is contradiction, because we know GCD of this one equals 1 based on the previous proof, which means we have no solution if n strictly superior than 1, which means the only solutions that we found, which is this one, okay? I have ended with this video. If you have any question or suggestion, just put it in the comment section below. Don't forget to support us with your like and subscribe. Thank you for watching, and I will see you next video. Bye.